Good evening, students. So, in this introductory video course for your analytical chemistry, we just say about something related to our objectives for this particular course, where we see that analytical chemistry, which is a very interesting subject, which can give us some opportunity to study and use sometimes the specialized instruments and techniques which can be used for specific methods to separate, identify and quantify any unknown substance. Suppose we want to analyze a material which is a solid material, and we know that some metal ion is present in it. So, how do we proceed for that? So, initially we should identify whether what type of metal is present. If it is copper containing material, we will try to find out the presence of the copper center over there or the copper ion over there. This is a typical aspect for qualitative analysis, and the qualitative analysis also tells us what other species is also present along with the major component which is your copper. So, this particular study, if we can go classically, suppose the solution techniques such as our qualitative analysis techniques such as we know from our school days, the flame test for some of these copper ions or sodium ions and such other ions. Similarly, we can proceed further to quantify the amount present in any unknown material. So, analytical chemistry will give us some idea if the species is complex, if the material is complex, we have to separate it out, we have to identify the individual components, and finally, we can quantify all the species present over it, which is under the domain of quantitative analysis. So, we can have two types of analysis initially apart from the instrumental technique. One is your qualitative analysis and another is your quantitative analysis. And the magnitude of this analysis will also tell us that whether we are determining the amount in terms of the gram scale or a milligram scale or a molar concentration or a millimolar concentration. So, we can go in that way to a corresponding microanalytical technique. So, when we use the different instruments, we have to consider the basics of the spectroscopic techniques. So, we should also know the different spectroscopic techniques in relation to this, some broad idea of all these things, because we have to apply all these instrumental techniques when we will go for typical instrumental analysis, which is a part of this analytical technique. And one of such analysis will be involving the atomic absorption spectroscopy, then atomic emission spectroscopy, and if we can go for the simple ultraviolet spectroscopy, that we all know that simple UV visible spectra of any colored substance will give us some idea utilizing the Lambert and Beer's law to find out the unknown concentration, whether it is a metal ion solution or an organic molecule having a chromophore which can absorb light and have a corresponding lambda max and epsilon max which is known to us. Then the fluorescence spectroscopy can also be useful to us. Then we will utilize the infrared spectroscopy, then Raman spectroscopy and Mossbach spectroscopy to analyze the iron samples. So, all these different instrumental techniques will tell us something which can further complemented by knowing the corresponding electroanalytical technique, where we will utilize the electrochemistry. The electrochemistry will be utilized to find out some very low concentration, where the concentration is in the range of 10 to the power minus 5 to 10 to the power minus 6 molar, where we can utilize the cyclic voltammetric technique, which is nothing but a voltammetric technique where we can have a current which can be derived from a voltammogram with respect to the corresponding potential. Then the amount of current which is passing for that particular type of reaction. Suppose we are considering some oxidation reaction, we can perform the coulometry, where the coulomb charge we can quantify, we can determine the amount of coulomb charge passed through the solution, and that Coulomb count can also tell us about the number of electron transfer for a particular reaction. Similarly, the ampere measurement can also give rise to some technique which is the corresponding amperometric technique. So, electroanalytical technique will be a very useful one for this particular course, and this course has thus a very good application and wide scope in forensic science, because we all know that analytical chemistry, if we go from analytical chemistry to a typical bioanalytical chemistry, we know that the doctors, the physicians, they use the clinical chemistry. So, analyzing our blood sample, analyzing our urine sample or any other sample from our body also is dependent on analytical chemistry, where we can find out the clinical analytical chemistry. In a similar fashion, the forensic science, if we want to determine very small amount which has a forensic relevance, such as arsenic. Suppose a person is poisoned with arsenic. So, how do we find from a sample of his hair or skin the amount of arsenic present in the body? It can come through the groundwater by consuming the water in the body. Similarly, any other biological samples such as blood, we can also analyze. Then different types of clinical analysis we can perform using the knowledge of analytical chemistry, and this knowledge of analytical chemistry will also be useful for us for knowing the environmental chemistry, because we know now that environmental samples which can come from our water. So, water can have some good idea what are the contaminants present in the water. So, we should go for the analysis of that water sample, as we all know that from our school days knowledge that the typical analysis of water, whether the water is hard or soft, that we determine the presence of corresponding calcium ions or magnesium ions. But if we can have very small amount at the nanomolar level or the micromolar level, we have to use some instrumental technique for identifying the corresponding contaminants which is contaminating the water sample. Similarly, we can analyze the air samples, and lastly we can find our application of analytical chemistry for the analysis of the different materials, because the materials can be a solid material, materials can be some electronic components which we all know that something which is part of a computer or some electronic material. So, that can be analyzed because all of them are made of some inorganic sample or the metal samples. So, individually the solution of those materials are a tedious task, and that we can study that how we can dissolve these materials to get some solution, and individually we can separate all these components from those materials. And with the knowledge of all these conventional classical techniques such as quantitative analysis or the instrumental technique we will use for the analysis of this material, that gives us a very good idea about the corresponding application and the strength of this analytical chemistry in analyzing any unknown material. Thank you.